Okay, students, this section we are going to summarize the alkenes and its addition reactions. Means alkenes undergo addition reactions. Okay, in addition reactions, we studied various types of addition reactions, isn't it? It may be halogenation reaction, that is addition of halogen atoms, addition of water molecule, that is called as hydration reaction, addition of hydrogenation, or addition of hydroxylation. Okay, let us summarize these things. Okay, so and we next move on to the another topic. Okay, so in this table we have concluded that they have summarized the uh, alkenes and its addition reactions. Okay, so first one you can observe, okay, that is called as addition of hydrohalogenation or addition of any hydrohalogens. Means for example, you can addition the hydrobromic acid, or it may be hydrogen chloride, or it may be hydroiodic acid. Okay, what you call this process as hydrohalogenation. Means what is added? The hydrogen is added and the X. Means X, it may be chlorine, bromine, or iodine. Okay, so the addition of any HX is called as hydrohalogenation. Okay, it follows the Markovnikov rule, isn't it? Okay, so then next one is the addition of water. Addition of water is called as hydration reaction. We already discussed with this one. Okay, so it follows the Markovnikov rule. Okay, this stable cation which is going to form, then the nucleophile go on attack. What it needs? Okay, it needs a concentrated H2SO4 medium or H strong acid medium it requires. So this is called as hydration reaction. Here we are adding the H2O. Okay, so next one is the hydrogenation. Hydrogenation is nothing but addition of hydrogen atoms. Okay, so the two hydrogen atoms is going to add it across the double bond. Okay, if you are going to use the metallic reactions such as platinum palladium, the syn hydrogenation takes place. Here we require a catalyst such as platinum or palladium as a catalyst or any other catalyst. This is called as hydrogenation reaction. Okay, so next one is the addition of halogenation. Halogenation means addition of chlorine, bromine, or iodine is called as halogenation reaction. Okay, so this undergo via cyclic bromonium intermediate or cyclic chromonium intermediate or cyclic iodonium intermediate. Okay, isn't it? This is called as halogenation reaction. Next one is the addition of one OH group and X group. Actually we have not discussed. Okay, in your syllabus it is not there, but you have to remember this. Okay, addition of one halogen atom, here one halogen atom, and addition of one OH group. Okay, it is called as halohydrin reaction. Halo means it is the addition of any halogens. Hydrin means it is the addition of OH group. Okay, one halogen and OH group is adding across the carbon-carbon double bond. You call that one as halohydrin reaction. Okay, so then last one is the hydroxylation reaction. Hydroxylation means dihydroxylation. We already discussed the addition of two OH group across the carbon-carbon double bond is called as dihydroxylation reaction. It is can be done by using the alkaline KMnO4, or you can use the osmium tetroxide or any other reagent. Okay, so this is the summary of alkenes and its related addition reaction, isn't it? Okay. Okay, so next one is the oxidative cleavage. Okay, here okay, up to this we have discussed addition reaction. Now we are going to discuss the one more types of reaction, that is called as oxidative cleavage. Okay, what is the meaning of oxidative cleavage? Means the carbon-carbon double bond, okay, which undergoes okay breakage and leads to the formation of the two separate compounds, or the alkene double bond is going to disintegrate. Okay, or the dissociation of the carbon-carbon double bond by using of the strong oxidizing agents, okay, is called as oxidative cleavage. Okay, so as the name itself indicates, we are using the strong oxidizing agents here. Okay, so there are many reagents are here also, there are many reagents are available to do the oxidative cleavage. Okay, so in this reaction, general reaction, you can observe this one. Okay, so here we have taken alkene and we are going to add the oxidative reagents. Okay, and there what happens, the carbon-carbon double bond is going to break and leads to the formation of two different compounds. This is called as oxidative cleavage reaction. Okay, so in this reaction, we are going to use the oxidative cleavage reagents. Here also there are plenty of reagents are available. Okay, so to perform the oxidative cleavage, okay, actually you have to remember this point. To do a particular reaction, okay, there are many reagents are available. For example, for oxidation, there are many reagents are available. Okay, organic reagents are available, inorganic reagents are available. Okay, so there are H2O2, okay, like that many reagents are available, but based on the availability and based on the situation, okay, and here we are discussing according to your topic. Okay, here we are discussing some of the oxidative cleavage reagents. Okay, what are those? The first one is the KMnO4 reagent under basic condition like NaOH. Okay, under the influence of the strong base like NaOH, the KMnO4, which is acting as a oxidative cleavage agent. And the one more reagent is the O3. The addition of ozone. Okay, ozone, you know that one, this is a molecule, okay, which is going to stable highly under very low temperature. You have to maintain the very low temperature for this reaction. Means why? Means if you are going to heat up this ozone, then you will get up with a one nascent oxygen and the oxygen. Okay, so when it is going to stable, the ozone, it is going to stable at the very low temperature, isn't it? Okay, so at very low temperature we have to pass this ozone gas, okay, by using some solvents like chloro, dichloro, methane, CH2, Cl2. Then this oxidative cleavage is going to happen. Okay, then by adding the methyl dimethyl sulfide, you will get the two different compounds or dissociated compounds. Okay, so let us discuss this reaction, addition of O3. The addition of O3 across the carbon-carbon double bond is called as one particular reaction, ozonolysis. Ozonolysis is the reaction where carbon-carbon double bonds gets break and leads to the different carbonyl compounds. Okay, based on the substituents you will get different carbonyl compounds. Okay, let us discuss this. Okay, so let us consider a reaction, a general alkene we have taken. Okay, the substituents are represented by the R, R dash and R double dash. Okay, so in this reaction what happens? So we are adding the ozone at a temperature of -78 degrees centigrade. Okay, so it is usually very low temperature. It is a stable molecule. In the presence of a dichloromethane, if you are going to add this one, you will get, okay, so if you clearly observe that one, okay, the carbon-carbon double bond is exactly cleaved, and what happens, okay, since it is the oxidizing agent, is carbonyl group is added to this one, and a carbonyl group is added to this carbon also, okay, which leads to the two disintegrated products or two different products, okay, based on the substituents. Okay, here you can observe, since one R group is there in or any alkyl group or aryl group is there, okay, and hydrogen is there, so that the compound we get here is a aldehyde. On the other side, since the two groups are R, it may be alkyl or aryl, then you will get a ketone compound, and the after the addition of this one dimethyl sulfide, you will get the dimethyl sulfoxide. Okay, then how this mechanism proceeds through? This mechanism is proceed through like this. Okay, the nucleophilic or electron rich alkene which comes and attached to this ozone. Okay, so here I have written the ozone. Okay, this is the one of the resonating structure. Okay, so what happens here, O is developed in the middle. O is developed with partial positive positive charge, okay, in its dipolar form, and the another oxygen is having the negative form. Okay, so what happens, the electron rich alkene which approaches the oxygen, then this bond is going to polarize, and now this oxygen, the third oxygen atom which attacks to the the alkene, okay, which leads to the formation of the one of the cyclic intermediate. It is called as molozonoid. Okay, so then what happens, this molozonoid is converted into, okay, so another intermediate, a highly unstable intermediate. Okay, this one. Okay, so how it comes molozonite to this one? Okay, so you need not mechanism for this one. You just, for the sake of examination, you just understand this. Okay, this molozonide, okay, again it is converted into this one. Okay, what happens here? Okay, the carbon carbon double bonds, both sigma bonds and pi bonds is broken, and as a resultant of this one, okay, these two oxygen is at are same side, and this is at the another side. Okay, so then if you are going to add the any reducing agents like dimethyl sulfide, or you can add the zinc and water, okay, or you can add some other reagents also, then you will get the end up with the product. Okay, so okay, so it's the one of the compound, that is dimethyl sulfide, is get converted into the dimethyl sulfoxide. Okay, so this is the way to identify, or this is, or by this way the ozonolysis takes place. Okay, so and the very easy trick is there, okay, to identify this product. Okay, so what is that easy trick is, okay, whatever the compound it is, okay, let us take in cycloalkene, cyclohexene. Okay, in this to this, if you are going to add the oxygen, then what happens? Okay, so like that you have to write this one compound. Okay, then what happens? Okay, so this bond is going to cleave like this bond is going to cleave like this. Okay, and this oxygen atom is going and attached to the sulfur atom, and it gets converted to the dimethyl sulfoxide. Okay, then what is the thing? Okay, see here you write, this is the thing. Okay, here what happens, this carbon carbon atom is going to break. Okay, so as a resultant of this one, this develops a carbon atom over here. Okay, and you will get one hydrogen here. Okay, here also what happens, here also this is going to add, it is called as one more hydrogen. Okay, so this is the way to write the, ozonolysis product. Whatever the comfort it is, you just break a carbon carbon double bond, you add a oxygen to the one. Okay, so sometimes you are going to get the aldehyde, sometimes you are going to get the ketones. Okay, sometimes you are going to get the formaldehyde. Okay, so like that you will get the product, isn't it?